for a problem with the sandboxing policy, being that our our testing application runs with the sandboxing policy of an App Store binary, we are not going to show you this payload, but we will show you a simple vibrate payload. So. So let me just create a network for the phone. Okay, so basically what we will do now is to use our test application to make sure that this payload actually is actually correct. So this payload is really simple. It's basically just call a function called audio services play system sound that basically make sure will make sure that your phone vibrates, and then it will exit, and that's pretty much it. And so this payload compiled looks like this. Okay, so like something like this, and now can't remember. Okay. Let me just. Sorry, I forgot to connect the iPhone to the test network before. Okay, is acquiring this IP address. Okay, so okay. So we run on the iPhone, the test application, and now if everything goes according to the plan, can you hear it? Okay. So this is basically how we test the payloads, and so enough with the demos. The future work. Okay. The future work. So, as Tim said, at the moment, the algorithm for finding gadgets is really dependent on the compiler and on the platform. What we are planning to do is to port the gadget, like the gadget finder, to other architecture like x86, so that it's possible to use the same algorithms for like Windows, Linux, OS X, and so forth. And a problem related to this is that we need to find to create like an abstract language to describe the gadgets, because at the moment they are, as I said, really architecture specific. So what we want to have in the future is a way to generically describe them, so that we don't have to have a different like interpreter for each architecture. And the third problem is try to avoid hard to solve problems by the constraint solver. So what this means is we want to find an algorithm that will basically select the gadgets so that they are the lowest possible amount of side effects. This way, the constraint solver will not face really hard to compute constraint to be satisfied. And finally, since on like x86 operating systems and possibly in a near future on mobile platforms as well, we're going to see the address space layout randomization. What we want to do is to make sure that our tool is kind of able to circumvent this. So what we're planning to do are mainly two things. The first one is verify whether or not it is possible to actually create meaningful payload without having Turing completeness. The reason behind this is in some address space, there are some specific libraries that are not randomized. So if we are able to create payloads just by just having a few gadgets, then we don't need Turing completeness, and unless the entire address space is randomized, the tool is still usable. And the other thing that we plan to do is to make sure that our tool is able to generate what is called an egg hunter, return-oriented programming egg hunter. So basically an egg hunter is responsible of finding other gadgets in memory so that you can basically form the entire payload in memory. So that's pretty much what we plan to do in the future, hopefully. And thanks for your time. If you have any questions. No questions? No questions?
I think up here you asked what kind of library we used on the iPhone, right?
It was WebKit. Yeah. Yeah.
How big it is? Yeah, you saw the compiled payload on the screen, right? I don't know.
I think it was about 1,040 bytes, if I remember correctly.
Anybody else? Yep.
How long did it take for the wolf to find the
Ralf?
Okay, the wolf is actually the compiler, so it doesn't locate the gadgets. Are you asking how long the compile time for the gadgets are? Okay.
So the compile time really is, it can be improved at the moment. So it's on the order of minutes, usually per statement. But this is because it's kind of an ugly construction. I trigger STP externally every time. I write to temporary files and all that kind of things. So this can be improved. Also, if we get the number of side effects minimized up front, this will improve as well. But to be honest, compile time isn't an issue in my opinion at least. I can do something else while the compiler is working for me. As long as it's correct and it is finished in a finite amount of time, it's okay.
Yeah, basically, you always have to think that doing this work is all done because you can spend your time with doing more useful things than going through IDBs and searching for specific instruction sequences and putting them together later on. Therefore, we did that so that we can spend the time with cooler things to do than this.
Anyone else? Nope. Okay. Thanks a lot for being here.